Welcome everybody to day 2, week 2 of Computer Science 41. So we're going to talk a little bit today about how to test your code. So some of you might have noticed that I didn't post the input tester online. And I did so for two reasons. The first reason is I thought it'd be interesting to see if you guys could figure out how to test code on your own. The second reason was because I forgot to. So testing. How do you test your code? Yep. So you run your code, right? It's add in 1/2 and 3/5, like that, and then you print them, and okay, all right, numbers are coming out all right. Let's add them. So let's add the two of these together, and the answer is 11/10. All right, so let's think about that. 1/2 is 5/10. And 3/5 is 6/10.
Stream.
I'm not streaming? Yeah, okay.
Yep.
If you insist. So so what you do is you run your code and punch in some numbers and look at the results and see if they're reasonable. Like, learning how to test your own code is really important. And I think probably the next assignment we're going to do is actually going to teach you guys how to test your own code, because it's a really important skill. You're not going to have a professor making test cases for you your whole life. You need to figure out how to assess your own program's correctness. Now, the reason why I do give you an input tester is because there's a format. Every time you output something, like, it's not clear. Like, should I reduce the fraction? Like, if I add 1/2 and 1/2, should the answer be 2/2, or should it be 1, right? And so there's a reason why I give you guys the input tester. It's because you need to be able to format your code so that it matches mine. But you might have noticed that in the README file at the very bottom, I have all the information you need to test your code, right? I give examples of every single operation you do in here, and so you should be able to test your code just based on that, right? And you need to learn to write a little bit of code, compile it, work through the compiler errors, and then run it, and then assess for yourself if your code's actually doing what you think it should. So get out a sheet of paper and do the fraction arithmetic and see if, when you add and subtract and things like that, you get what you want. And one thing that you should probably think about is, like, 2 minus 3. So 2 minus 3 is bad input. And the reason for that is because when you do an add or a subtract or something like that, you actually add it to the vector. So if you add, here, let's run that again, 1/2, 1/2 together. If you add those, the result is 2/2. And if you print all of your fractions now, you'll see that the result of every computation gets added to the end of the vector. Okay. And so it's not reduced. But the reason why you can't subtract a small number and then subtract a bigger number from it is because you're not allowed to have any negative fractions in this world. Our fraction class has an invariant that says you cannot have a non-positive numerator or a non-positive denominator. And the reason why we do that is to make the Egyptian fractions possible. And this is something that probably most fraction classes won't do, because it's perfectly reasonable to have a negative fraction, right? -1/2 is 100% okay. But for our particular assignment, because we're making a fraction class for Egyptian fractions, we have this class invariant that says you cannot have a non-positive numerator or a non-positive denominator. And if you ever try creating a fraction that has a non-positive numerator or denominator, then the thing will call the die function. Okay. The do not edit me file does the same thing also. I don't necessarily check the get function for printing them. F3 is declared, and then it equals F1 plus F2. Yeah, okay. All right, so yeah, testing your code is good. And so what a lot of you guys should probably do for this class is make a main.cc and like, you know, include fraction.h and then main. And this is how you can test your class, right? You can say fraction f1 and f2. If you want to be super cool, you can include my read header file. And then you can say fraction f1 equals read, please enter the first fraction. And please enter the second fraction. The read library works with your new type as well. The reason why it works with your new type is because the operator double right arrow is defined on it. Okay. So yeah, so that'll read in a couple fractions, and then you could do something along the lines of fraction f3 is equal to f1 plus f2, cout f3. So this would be a good way of you testing your code, right? This is called a driver. Okay, enter the first fraction is 1/2, second fraction is 1/2. The answer is 2 2s, right? And so this is called a driver. This is a driver.
Wait, can you do the f1 plus f2 inside the cout at the same time?
Yeah. Let's see. Let's see if we can figure out why that's not working. Okay. Does not like that. Invalid operands. It's because you can't pass it by reference, I believe. Because it takes a fraction by reference, and this is an R value. So this is creating a temporary value. It's not actually. It's like you can't pass a number by reference. You can only pass it by value. And so if you wanted to have that work, then let's see here, fraction h. Where are you? Search for double left arrow. There we go. Wonder if this would work. I very rarely use R value references. Yeah, that doesn't work. Okay. Yeah. We can just pass it by value, I guess. It's only two. See how that works? It makes a copy of it. That's fine. And if we do f1 plus f2, then the result of that will be copied in as well. You can't pass R value. Let's see. You can't pass anything that's not actually a variable. You can't pass by reference, and so that's why you had to do it that way. But passing by value in this case, or you can copy and paste it and have one by, whatever. So that will work fine. Okay.
When you say an R value, do you mean like a literal, like a?
Yeah. So like so when you say like an L value and R value, an L value is anything that can appear on the left-hand side of an assignment operator.
Okay. Yeah, I see.
So
they can't do like 3 equals X.
Yeah, so you can't do this, right? That doesn't work.
Right, because that's an R value.
It's an R value.
I see.
F1 and F2 can appear on the right side of an equal sign, but it can't appear on the left hand. Actually, it is. It's bizarre. Okay, but like you can't say like 3 plus 5. You can't say 3 plus 5 equals 7.
Right, and the only reason you could actually have that on the left-hand side before was now because you changed it to be passed by reference, right? Because now it's no longer an R value.
Yeah, so now I'm passing it by value, and so now this temporary value here can be passed in because it makes a copy of it. So yeah, a little bit of a terminology. F1 equals F2. Okay. F1 is the L value. F2 is the R value. And in C++, they've added PR values and the taxonomy of like things and where you can pass them and how you pass in R value references and all this stuff. It gets complicated. But the basic terminology is that anything that can appear on the left side of an equal sign is something called an L value, because L stands for left. Right? Does that make sense, Amelia? And the rest of the class, because you guys should be learning this too. It's time. Amelia, you with me on this? Cool. So because F1 can appear on the left side, it's an L value. It's also an R value, right? Like F1 could appear on the right side as well, but we call it an F value, an L value, because only like proper variables can appear on the left side. Okay.
Can't basically any L value be an R value as long as it's assignment operators, or I guess, like.
Yeah.
Is there really any situation?
Yeah, like if you don't have a copy constructor.
Yeah.
You know, or the assignment equals.
As long as the operator's defined for it, like you can have it.
In general, an L value can do more things than an R value, right?
Right.
And so, like, if we were to do like this, this is an R value, right? That doesn't actually have a variable name. You see that? Mm-hmm. Like
you can't say read equals F1.
Yeah, like you can't pass this by reference to something because you can't change it. Right, the result of a function can't be changed, right?
Yeah, and it isn't in the technical sense like why that wouldn't work. Isn't it because like that literally does not even like hold the spot in memory as like an actual value?
Correct.
It's just waiting to be assigned to a.
Right. So, for example, that's a great way of putting it. So I can output the memory address of F1 if I'm curious about it, which I'm actually not, but this will serve to make the point that you just made, right? So I can print the memory address of F1, right? Will you?
Yes. Sorry, I didn't know you were asking.
Yeah. Here, we'll just have a conversation, and then everybody in the class should be able to. Is everybody able to see the stream? By the way, are we over the limit for? Are we over the limit for streaming?
We are at 30-something people. We're good.
Cool. Good. More people drop, the smoother the class goes. I just need to give a really hard homework assignment right now. Okay. Mm-hmm. So this will print. This prints the memory address of F1, and the reason why we can do that is because F1's an L value. But we cannot print, for example, the memory address of let's call the read function, right? Read in an int from the keyboard. This will not compile because the value returned by the read function, which is going to be an integer, it's not a variable, right? It's just like what you said. It doesn't have a memory address. It's just a value. It's a value
it's waiting to be assigned to something, or
exactly.
It's waiting to be put somewhere.
And so cannot take the address of an R value. You see that? You guys all see that? See? R value. This is part of the terminology that what do they say? It's the word of the day, you know.
Yeah.
So R value and L value is the word of the day. So R values are things that appear on the right side of equal signs, and you can't even like give me the address of the number 5, right? Like you can't do that, right? You guys understand?
Yeah, that makes sense. I've always like known that like there was a difference between like things that could be on the right hand and the left side, but I'd never thought about the actual terminology R value versus L value.
And I'm not making it up. Like you can see it right there. There's L value. The compiler uses the term L value and R value, and so only only L values can be passed by reference. Okay. So if I have int print int, and I take an int by reference, all right, you guys with me? Did I break something? Oh, no. So, Bob is equal to 42, print int Bob. Okay. Do you guys see how that works? I'm passing this variable here. This variable has a memory address. It's passing it to print int. And the reason why that matters is because when you pass something by reference, it's actually passing in the memory address of that variable. It's actually a reason why you should take CSCI 45, right, Muya?
Yes.
It actually starts making more sense when you actually see what is actually getting passed to print int here. It's actually passing to it the memory address. That reference there isn't just, some meaningless term. It actually means pass in the reference of the variable Bob in this case. Okay.
So now if you just put 42 into print int, it won't compile because 42 itself doesn't have. You can't pass 42 by reference.
Exactly right. And so if I pass in 42 here, this will not compile because 42 doesn't have a memory address. That's it's not a variable. And so if we come over here, you can see the bright fuchsia on pink error message. No matching function called to print int. Because it won't. It's not a variable. And so what you could do
it doesn't see it as an actual integer or it doesn't see it as a integer by reference.
Yeah, and so in this case we can make a version that had call by value, right?
Oh, so you could actually do that for the OStream overload too.
That is correct.
You could just make one that
you can make one that's by value and one by reference. Either L value or R value can be passed by value because it makes.
What was that double reference thing you did?
It's called an R value reference, and don't worry about it.
Okay. Because I know that you can like find the you can obviously find the memory address of a variable by putting 1%, but then if you ampersand that pointer that you essentially get out of it, you can get the pointer to the pointer.
You get a pointer to a pointer, yeah. But the R value reference is we'll be talking about how to move things, and we'll have that discussion then.
I've never even learned about that.
It's a modern C++ thing, and so modern C++. There's a huge optimization that can take place by not. So a big design goal of C++ is to not copy things, right? It's like if you have a vector, you don't want to copy all the elements of the vector ever, right? Unless you're like explicitly like, I want to duplicate this vector. You with me, Muya?
Yeah.
And so what if we had a function that made a vector and then returned it, right? And so there's you can we'll have a lecture on it. But basically the upshot is you can move something out or in without having to do a copy. It's a lecture for later. Okay. It's a very nice optimization, and C++ has been pretty good at coming up with ways of eliminating any sort of redundant copies. Java almost does a better job though, because in Java everything, the only thing that are not pointers in Java are basic primitive variables like Bob here. Literally everything in Java, the rule in Java, okay, this is actually good for you guys, okay, because it's a rule in Java, but it's a rule that you guys should follow in C++ as well. You guys ready for this? Rule of thumb. You guys ready? Follow the Java rule of thumb that they made baked into the language is actually really good for C++. Yeah, you guys don't need to say tilde here. Like, I don't know why you guys are all doing that. You don't need to do that. Just say something. And woo, look at that. That's a hell of a thing. Okay, rule of thumb. Rule of thumb to follow when making functions. Primitives get passed by value. Objects get passed by const reference. Okay. That's the rule of thumb. Exceptions exist. For example, if you want to duplicate a vector, then you would pass the vector by value. If you want to change an object, you pass it by reference instead of const reference. But in general, like this function here, or let's do the whatever. Yeah.
I guess we should specify primitives are basically anything that turns green when you type it.
Yeah, that's a good
like
way to put it.
Really anything that can be like really easily represented in binary, so like ints, chars, floats, doubles,
Yeah.
int 32, size t, they're all the same thing, but yeah.
Yep. Your basic, you basic.
They're like the types that are literally in every language, no matter what, because they have to be.
Mm-hmm. So that is that's the rule of thumb, and exceptions exist. Exceptions exist. Like if you want to duplicate a vector, like I saw a lot of people on the write something like this. Like if you have a print vector function, and they're having a vector of let's say fractions. Why not? We got fractions. Vector of fractions named vec. They'll do it this way. Do you guys see what's vector? Oh no, vector. And then they'll do something like this for every fraction in vec. See out that fraction. So what two rules did I violate with this? What two rules did I violate with this function here? I see students writing code like this all the time. Which two rules did I violate? Vector is passed in by value. Yeah. So what that's going to do? Let's say the vector has a million fractions in it. Whenever I call this function and print it out, it will first duplicate. Call by value means duplicate the parameter, clone it, and so it's going to clone a million fractions, and then print it, and then the clone goes away, and that's incredibly wasteful in terms of time. You won't notice it here because I've only got two fractions. It'll be a blink of a second, but and students just write this because it's like, I don't understand call by reference. I'm just going to make everything call by value, and then their performance tanks, and they don't know why. So this is the rule of thumb. Okay, you should just do that by default, and then if you run into problems, like with the cout, like some of you guys are trying to see out a fraction, and that's the result. That's a temporary because it's the result of a thing, and you're running into trouble. Then then you can work with it. This is not a hard and fast rule by any means. This is not a hard and fast rule by any means. Okay, so so the first mistake I made here is I passed it by value. If I pass it by reference, it'll work exactly the same. In fact, let me compile it, run it, 1/2 and 3/5. Okay. We don't need Bob anymore. And so you won't notice any difference if you make it call by value or call by reference. I run it again, 1/2, 3/5. Looks exactly the same. But when you have it call by value, it is duplicating the vector. And if you have a million billion elements in the vector, it's just going to slow everything down to a crawl. It's not passed by something, it's not passed by reference. Yeah. And so the other thing is this guy here is being called by value also. So it doesn't look like it, but that's how you should do it. Okay? It should be called by reference instead of called by value because it's an object. An object is anything that's a class. Anything that's a class type, basically, by default, you should pass by reference. Now, what's the other rule that I broke? Okay, there's actually three. There's actually 4 changes I should have made. There's 4 changes I should have made, not just 2. What are the other 2? There's 2 more words I need to add to this to be in line with the rule of thumb. Okay. What do you guys think? Class or struct. Yeah, strings are not primitives. Strings are actually part of the standard library. They're not part of the language. They're not part of the C++ language. F was not initialized. F is initial. Yeah. So in this range-based for loop here, it says for every fraction in the vector, print that fraction, and this will be initialized every time. The first time through the loop. Good question, Miss Crump. The first time through the loop, F will be set to the first element of the vector. The next time through the loop, it'll be set to the second element of the vector. The next time through the loop, it'll be the third element of the vector. And so, yeah, that's good. What else do I need to change? Look at the rule of thumb. What else do I need to change? Const, very good. So, I'm part of the West Const people, West Const crew. There are East Const rappers that will disagree with me, but I'm part of the West Const gang. So, yeah, make that a const. Make that a const. What is it? Why const? What does const mean? Const means you can't change it by accident. Okay, and so if I were to do something in here, like say vec.at 0 is equal to fraction 0.3 or something like that. Like if I tried changing the vector by accident, the compiler will catch it. Okay, and so if like a print function should not be modifying it. You know what I mean? A print function should not be modifying the vector, and so by putting const there, then the compiler will help you. The compiler will be able to help you, and if you goof up and you shoot yourself in the foot somehow, it'll throw an error. It'll be like, sorry, you tried changing that. You can't do that. And you notice that here, before I put the constant here, it was throwing a error. And the reason why it could throw an error is because this would allow me to change the vector. If it's not const, I could change the vector through f. And so I could set f equal to 0 or something. And so I have to make this const as well. Okay. So some people are West Const, other people are East Const. Let's see if I can do this right. Const like that. There you go. Those two things mean the same thing.
Didn't even know you could put the const on the other side.
Yeah, it's because you grew up with a West Const professor.
Yeah, well, yeah. West Const for life, so.
That's right. So, yeah, Tupac versus Biggie, right? So, Tupac put his West Const and Biggie is East Const. Is there some particular reason some prefer East? I'm sure. Like people get really chuffed. They get really mad over these kinds of things if you don't do it the right way, and it means the same thing. It means the same thing. And people will argue online, which is better, and frankly, honestly, it doesn't matter very much. Just be consistent, you know. Tupac, the hacker, versus Biggie. I used to ignore using const when you do bigger codes or share your codes for a greater project. It really shows the importance. Yeah, const is actually, it's actually really important. And more importantly, it actually conveys meaning to somebody. Because when somebody is going to call print vector, they're going to look at the signature. They're going to look at this, okay? And they're like, okay, the function doesn't return anything. It's named print vector, and it takes a constant vector of fractions by reference. Okay, cool. I know what this function does now. I don't even need to look at the rest of the damn thing. But just by looking at this thing, I know exactly what it does. I'm going to pass it a vector of fractions. It's not going to modify it. I don't need to worry about it modifying it. I don't need to look at any of the code between the curly boys because it is a const parameter. It is it's not only a safety measure for you, but when people use your code and call your code, they look at that and be like, okay, yeah, I don't need to worry that this thing is going to change my vector if I pass it in. And if it's not const, then people would worry. They're like, why is that not const? Because this is the rule of thumb. And really, it's a standard thing, right? The Java language made it Well, the Java language made everything reference, right? And you can make it const reference, but Java made every object. Every time you have a function called to an object passed to a function. I mean, every time you pass an object to a function, it is by reference. Every time. If you want to clone it, you have to explicitly call clone. Ints, floats, doubles get passed by value. They get duplicated. Every object in Java gets passed by reference. Okay. And in general, you want to pass things by const reference if you can get away with it. If you're going to change it, like if I'm going to make a function called like void clear vector, then it's just going to be by value, right? Like if I'm just going to delete all the people out of this vector, like I can't pass it by const, right? So vec.clear, yeah, something like that. It's kind of a pointless function because that exists. But do you guys get the point? Like if you're going to destroy the function, or if you're going to add things to the function or the vector, sorry, if you're going to add things to the vector or delete things out of the vector, then yeah, you can't pass it by const, right? That's why it's called a rule of thumb. You know, then you would just pass it by reference. Okay. So for setters, you never use const. Yeah, exactly. Setters will never be const, but getters will always be const, or they should be. Okay. And so when you're making a class, there's another use for const. There's another use for const, and that is here. So it's not here. Okay. Like this. Like I could make this const, right? And I can make that const if I want. Maybe I should. Technically showing you guys the answers. Oh well. This is actually the answer to your homework, so there you go. There's a free page of working code. So people will be bookmarking this on their streams. Okay, so here I made this parameter const. This is actually, do you see how it goes in a different place from this one? So your getters should always be const, and that's called a constant method. So this is a constant parameter, right? Because the parameter to a function is something you pass to a function. That's a constant parameter. This is a constant method. A method is a member function, okay? So this is a constant method. And what that means is it will not change the object that you're on, right? Do you notice how it doesn't assign anything to the class? This one does. This one can't be const, but this one should be const. Getters should always be const. They're sometimes called accessors, and setters are called mutators. And it depends what part of the country you're in. Sometimes people will make fun of you for calling it a setter, like because that's a type of dog, right? Setters. And I was watching a talk the other day, and the guy was calling pointers putters. That's a putter. It's a const putter. I was laughing. I'm sorry. He was from San Francisco, so I don't even think it's like a regional thing. It's just a him thing. Yeah. So the const here is not only a safety, because this will, this will prevent you from like a get function should not be modifying the thing, right? If you call f1.get numerator, that shouldn't be modifying the fraction. Do you guys understand? Like if I'm just like trying to read out the fraction, if I'm trying to print the fraction, that shouldn't change the fraction. You guys with me?
There's also if you make a function that passes a class by const.
About to talk about that. Yeah. Mm-hmm.
Yeah. You can't use non-const functions.
Yeah, that was my next sentence actually. But yeah, thank you for pointing that out. There's two reasons. One is it stops you from accidentally doing something you shouldn't be doing, and the other thing is if you pass something as const reference, like let's do it down here. If we pass it by const reference, the only member function you can call. You guys see this guy here? He's now const reference. If I did, if I just, I don't know, called f.get numerator, that works. And the reason why this works is because it is a const function. Only const functions, const methods, only const methods can be called on const objects. Okay, and so this and this go together like peanut butter and jelly. I used that analogy last time, but whatever, I'll stick with it. So f can only have constant methods called on it. If I tried calling f.setNumerator, watch what happens. You guys see that? So because I'm passing this guy in by const reference, which I should, because this is a printout function. The printout function, it should be passed in by const. I didn't put the const there was because I hadn't had this lecture with you guys yet, and I didn't want you guys to get tripped up by this problem. So this argument to member function setNumerator has type const fraction, but the fraction is not marked as const. Can you guys read the neon glowing radioactive pink there? The error is I'm calling a non-const method, this guy. I'm calling a non-const method on a constant variable. Can't do that. You guys see that? Does that make sense to you? This is actually a really important rule. This is a really important rule because for your next homework assignment, if you don't do your const methods right, you will get this error message. How do we get that error to highlight on your screen? You can't. It's only a professor thing. It's a dark secret. Okay. Did I break anything? Okay, it's back to normal. No, but seriously, if it's a Vim plugin called Cock, so yeah, I might have to censor that in the YouTube stream. But it's called that. If you want to look that up, it's a Vim plugin called Cock. So there you go. Enjoy. You might want to put safe search on before you start searching for Cock on Google. But and that's the name of it. Okay. And what that does is that does the error highlighting, right? Like if I forget the parentheses, like that, then it Cock shows the error message here. Amber Crump shows a bowling ball hitting. Very nice, very nice. All right, so yeah, and so if I tried making this const, do you guys see how that doesn't make any sense? This deletes a vector, right? And so you, right? If I pass the vector in as const, you can't delete it, and it'll throw an error. Okay, so the yeah, it's not something that Jedi would tell you about. And the reason why I don't have it installed by default is because when everybody uses it, it slows the server down to a crawl because it's constantly compiling the code in the background, basically. So I don't. It's installed on the server, but I'm not going to tell you how to get it to work because the server cries when that happens. Whenever we upgrade to the new server for the department, then maybe I will. We had a really nice machine donated by Courtney Choate. Her husband works in IT, and he donated this very nice Xeon server to the department. And we're still in the process of getting it set up. Okay, so that is good stuff. All right, so we're at the halfway mark in the lecture. Let's talk about what we're going to talk about today, which is we should probably talk about copy constructors, assignment operators, deep copies, shallow copies. Yeah, let's do that. Okay. Any questions about this? L value, R value, call by value, call by reference. This rule here. The const obviously is not. It should, by default, you should pass something by const reference like this. But obviously, if you need to change something, you don't pass it by const reference. But you do pass it by reference. So maybe maybe I'll make this get passed by reference. And if you are not going to change it, make sure it is const reference. Can a const method be called on a non-const variable? Absolutely. So, get numerator can just be called on, So like if I'm down here, I could see out f1 dot get numerator. Right, works fine. Const only restricts, it does not, it's a safety measure. And so it works basically the way you think. It just prevents you from changing something accidentally. Okay. Will the code notes be available on our end? Sure, I'll put it up on the public directory today. Okay. The method itself is not allowed to change anything. Yeah, and it shouldn't, right? Like if I call get numerator, it would be really weird. It would be really weird if get numerator changed the numerator. You know what I mean? Like people would get mad at you. Like you release your function, your fraction class into the wild, and people call get numerator, and sure enough, it returns 3. And then the next time you call it, it returns 4, and you're just like, wait, what? Like what? Yeah, I thought I was getting the numerator, man. Why are you doing this? Should I talk about mutable? Should I talk about mutable, Muya? What do you think? Should I talk about mutable?
Go for it.
All right. I'll go back into the solution here. Let's not scroll around. Damn it. I might be giving away too much of the assignment though. So let's say you do want to change something inside of get numerator. So why would you do that? So one thing that people will do is they will count. They will instrument their code. They want to count how many times does this function get called, right? So if I have a static variable named counter, a static variable is a global, what's the best way of putting it? It's a global that's only accessible within this function. And so this value does, no, this is going to get too confusing to people. I'm not going to go there. I'm going to leave out static and mutable for another time.
I've used mutable, I think, once.
Yeah,
and I ended up refactoring my code, so I didn't have to use it. I think
it's going to explode their heads, and it's not really as important as what I want to talk about today. So, static doesn't have to have a type. It does. Yeah. So
you can have static voids, right?
I don't think so. Static void bomb.
Really?
Can you do that? No.
Oh, I thought you meant like as a method.
No,
like
I'm making a variable here named bomb.
Oh, a static variable. Wait, you can make static variables inside of functions?
You can, and that's a global variable that you can only access inside of that function. So this is actually
makes no sense.
It's a global that is local, and so it's a global variable. So it's the same thing as if I had made the counter as a global, like up here somewhere.
And you can only access it in the function.
But you can only access it inside of that function, so it doesn't pollute the global namespace. And so
does that do anything?
Yeah. So watch this, counter plus plus, and so what I can do is this variable here, counter. This variable will count how many times people have called get numerator. Do you understand?
Oh, so it doesn't actually. Oh, because it's static, it doesn't get reset every time.
It doesn't get reset.
That line of code only runs once.
This line of code, you can imagine it up in the global namespace up here as a global variable named counter. But
that's actually really cool.
This will run every time. And so, yeah, so you can have a separate counter for get numerator, get denominator. You don't have to have counter 1, counter 2, counter 3. You can just kind of put this code into every member function you have, and then every time you call get numerator or get denominator or whatever, it'll just increment it. And then in your debugger, you can just look at it and be like, oh, that was called 500 times. That was called 0 times. Okay, that's a problem. You know, so yeah. Anyhow, I'm like I said, let's not worry about that for now. Let's not worry about that for now. I've revealed too much of the answer as it is, I think. Static and const are different. Static and const are completely different. Yeah, static sounds like it doesn't change. Static is a really badly named keyword. Static sounds like it's not dynamic, right? It's static. No. No. Here, let me show you. Static int counter equals 0. Counter plus. Cout print int has been called counter times. Okay. And so if we call print, there's lag, which is making it really hard to type. Print int 42, YY 9p, so we're going to call print int 10 times, right? Do you see that? The counter does not get reset every time you call the function. If that was just a normal int, if that was a normal int, every time you called the function, counter would be reset to 0, right? See, it gets reset to 0 if it's a normal int. But if it is a static variable is a global. So it this is exactly the same as if I wrote it up here, like this. Okay, this code's the same. But now all the other functions can see counter. And if they have their own counter, like if we're instrumenting all our functions, then that gets very confusing. And so what you do is you make it static, and a static is a global that's only visible within that function. And so each one of them can, can instrument their code and count how many times the function gets called. It's a fairly common thing to do because computer science people are curious how often things are getting called. And then, you can print out how many times it's been called. What are some real-world uses for using static? This is actually a very common use, where you just put this into every one of your function calls, and then every function call, when it gets called, will increment a counter, and then at some point, you've been running your program for an hour, you open up the debugger, because the debugger can look at, it can look at variables, and then you can go in there and you can look at all the different counters and see, get a counter count, or you can print them if you want. That's a very common usage. There's also something called the Singleton Pattern. The Singleton Pattern is a class that can only be created one time, and so they'll use something like that to, say, have I been created, yes or no, a static boolean. So could you, or maybe probably like a class variable, there, but that's a general idea. It's any place where you'd use a global that you don't want to have just hanging out in the global namespace, because you would this counter would have to have a different name than this counter. This would have to be counter 1, and this one would have to be counter 2 if they were globals, because you can't have the same name, right? So you'd lose track. All right, I'm on counter 478, 76. Can you make a static vector and push back into it? Yeah, sure. It's pretty common, actually. Can you static the same way in for while loops? Static, no, static is just for variables. It's got some other uses as well, but in this sense, it's just it just puts a global variable into the local namespace, into the function's scope, I guess. Static instead of a function. Oh, yeah. Yeah, we should probably. Yeah. You guys are asking good questions. Got to answer it. Okay. Now, So let's say you're making a bug class, an insect class. Let's make it a struct just for simplicity. So how many legs do insects have? So we could do this, you know, like int name equals Monoptera or something like that. I don't think they're actually insects, but and it's not an int either. Yeah, very good, very good there. Okay, legs equals 6. Okay. About 250, 350. Okay. Yeah, so it's a little bit weird, right? Because you know, I mean, I guess Hymenoptera is actually moths. I don't know if they have 6 legs or not. Maybe they do. Can anyone look that up? And so if you're having like the ability to like, I guess, shoot insects and hurt their legs, this would make sense. Because every insect you create would have a legs variable on it, and it would track how many legs that particular insect has. But maybe you don't want to do that. Maybe you just want to make it a constant, so you can just, you know, if you have a structure like a dog or something like that. At most 6. But this is also kind of weird, right? Because like it's a little bit weird. And the reason why it's weird is because D10D, dog, old yeller, see out old underscore. So if you want to find out how many legs an insect has, you kind of have to make a variable, right? Like, if you want to find out how many legs dogs have, you'd have to make a variable of type dogs and then call the dot legs member variable. Hymenoptera 6 legs. Okay, excellent. Okay. And if I wanted to make a insect named B, if I want to find out how many legs an insect has, I have to make a variable of type insect b dot legs. Do you guys understand? And that's kind of weird because, like, shouldn't I be able to find out how many legs an insect has without having to make a variable of that type and then do that? Are you guys with me on this? Do you see how that's like kind of weird? It's a little bit weird. Because what I want is just like, you know, just the class. Everybody in that class has 6 legs, right? So there's no reason to actually instantiate it. There's no reason to make a variable to find it out. And so, so there is another use for static, and I promise it's actually useful. I'm trying not to go too far down the C++ trivia hole. But you can say static constant, make that not a constant anymore. So maybe that's the legs, one particular, I don't know. Okay, static constant legs, let's just do this. Legs equals 6. Okay. So did you guys see what I changed? So rather than being a constant integer named legs, it is now a constant integer that is static. Do you guys see what I did? I also capitalized it because I normally capitalize caps. Or I normally capitalize caps. I normally capitalize constants. You guys see that? So it is a static constant now. And so what static means here is that it is associated with the class and not an object of that class. It's associated with the class. That means every insect has 6 legs. Whereas here, you would track the number of legs on each individual dog. And there's 2 benefits for that. The first benefit is that this actually takes up memory, right? Because every time you make a dog, it's going to allocate memory to hold the number of legs that dog has. And they're all going to be 4. So it's completely wasteful of memory. When you do it this way, one place in your program is going to have this constant here saying 6, and it will probably be optimized away, actually. And so that doesn't take up memory. This, every time you make a dog, it's got to make a variable that holds how many legs that dog has. And it's always going to be 4, so it's completely wasteful. And the other thing is that you don't actually need to make a bee to find out how many legs an insect has. You can actually now access it directly. So yeah, Emma Iskandon is completely correct as usual. And the answer is B. This won't work anymore. Instead of that, because that won't work anymore. Instead, we don't even need the B anymore. Here we go. We can just see out insect : legs. You guys see that? This looks different, doesn't it? It's not using the dot operator. The dot operator means that's a member variable of an object. That's asking me how many legs does Old Yeller have. Okay, and this is saying how many legs do insects have. So Old Yeller is an instance of dogs. I'm throwing out object-oriented terminology at you guys now. Old Yeller is an instance of the class dog, and that's a member variable of Old Yeller. This is a static variable now. Static variables are associated with a class. They're associated with a class, not with an object. And so you access it by using the double colon, the scope resolution operator. Okay. Just had a lab in CSCI 26 that had us use that format. Yeah, it's pretty common. This is very common. Bees don't have legs. All insects now have 6 legs. And so this would be useful. This would be useful if you are, for example, playing a video game and maybe animals could lose their legs or something. Then you would want to do it this way so that you could go like, Old Yeller got shot. So, sorry, spoilers, my bad. So Old Yeller got shot and he lost a leg, right? In which case we would need to make this not const anymore. Okay. And so in that case, that would be tracking the amount of legs each dog in the world has, and you could, damage him or whatever. I'll probably do it this way. So that would decrement the number of Old Yeller's legs and then print the result, which would be 3. And then this is always going to be 6. So if you want to say how many legs do insects have, use that. Okay. Yeah, it's an old movie, so it's too late. If you want to have your heart broken, go watch Old Yeller. Okay, so let's come to the point of the lecture today. All that was actually very useful, and all that was very important, but let's come to the point of the lecture today. So we talked about testing. So this is a driver, right? Let me just finish my point on that. Driver is a small program that tests your class or whatever. Okay, and so basically when you're testing your own code, just make a little main, make a couple variables of your thing, add them together, subtract them, test. It's just a little tester. It's a little testing code. Okay. And this is how people develop code, right? So there's drivers and stubs. We talked about this in CSCI 40. A driver is a small program that all it does is it just tests your code, and a stub is you have main built up, and a stub is just a dummy function that allows main to work. And so by using drivers and stubs, a fake function that lets people call it compile. And so by using drivers and stubs, you can get your code working. Basically, you should get into the habit where your code always compiles. You can always run it. You can always test it. Don't be one of those students that tries coding everything at once and then hits compile at the end, and there's 5 million error messages, and you don't know why, and then you have to sit down and work through it for 10 hours and you quit. No, you should be writing a little bit of code at a time and then compiling it and testing it. And drivers and stubs are your way of making that happen, right? Okay. So okay. All right. So let's talk about the real topic for today. And so let's say we're going to make a new class, and this class, let's say we're going to make a vector class, right? So how, where do vectors come from? Vectors are not actually part of C++. They're not part of the C++ language. Let's put it that way. So C++, the language, has no idea of anything called a vector. It doesn't know about it. So where do they come from? It comes from the standard library. So when you include vector, that's kind of a giveaway that it's not actually part of C++. If it was part of C++, you wouldn't need to include it, right? You wouldn't need to include it because you could just be like int. You don't have to include int. Int is int. It's part of the language. All right, are vectors in CPP the same as in math and physics? No. So a vector, well, yes, but also no. So the technical definition of a vector is a 1D array. So it's just a line of numbers, right? And so a vector in physics is 3, 4, 5. It's just a 1D vector, a 1D array of things. And they use it to show magnitude and direction, right? But what technically a vector is just a 1D array. And so, for example, music is usually held in a vector. It is a 1D array of amplitudes. If you've ever looked at like a wave file, that's really all it is. It's just a 1D array of amplitudes, of the volume coming out of your speaker. And if you have a 44, kilohertz, audio track, that means 44,000 times per second. It has the amplitude of the sound coming out of that precise moment in time. So, and then there's transforms you can do on vectors and things like that don't matter right now. So, good question. They don't have magnitude and direction, if that's what you're thinking. Yeah. Are you thinking of? Yeah, there it is. There it is. The despicable me. Okay, so let's make a vector class. Let's just do this real fast. I'm going to make it a capital V, like that, and let's make it a vector of integers. Okay, and so behind the scenes, there is going to be an array. All right, there's going to be an array behind the scenes, and I'm using a pointer. You might notice I don't usually use pointers, and the reason why I'm using a pointer is because, well, that's how vectors are made behind the scenes. So they're hidden behind the paywall. Publicly, though, we're going to have a default constructor, and the default constructor is going to set R to be null. And that's about it. And we're also going to have to keep track of how many elements we have. And that, we can just do it this way. Null putter. And size is equal to 0. So we don't even really need this guy anymore. He can go away. All right. Do you guys remember what the constructor for vector does? Office hours today, no. 11 a.m. every day. What kind of stuff is in C Standard Lib? That's the C Standard library, or part of it, at least. A lot of useful stuff's in C Standard Lib that they just never bothered re-implementing for C++. So, yeah. So if I were to just let's come down here into main. This. And say vector vec. This is going to make a vector of size 0 because this is going to call the default constructor. Okay, that's going to call the default constructor. But what does this mean? If I were to make a vector like this in C++, It's C++'s vector. How many elements would that make? How many elements would that make? 10, right? So we're going to need a constructor that takes a size. Okay. So the vector taking in a size t, new size. And so in this case, we're going to set size equal to new size. Ooh. Now is a good time to introduce shortcut notation. So size is equal to new size. So this little bit up here does the same thing as this here. And this is actually preferable.
I forget what this is called. Is it an initializer list or?
It's an initializer. I don't think it's an initializer list. I think it's just an initializer.
Okay.
And so you might see the colon there, right? Which is new. You guys have never seen that before. And that's an initializer. That will initialize size to be new size. It does the exact same thing as that, but with one very important difference. If this was a constant, this would not work, because you cannot assign a value to a constant. Okay, but you can do that, because the value of a constant can be assigned when it is created, and so this actually sets the value when it's created. It overwrites that equals 0 there. This cannot be done. That will throw.
Yeah, I actually just checked, and it is called, like, if you have more than one thing, that is the C++ term for
the initializer list.
Yeah.
Yeah.
I remember learning that in the Bucky days of just before CSCI 40.
Okay, so yeah, this is called an initializer, and that will initialize size to be new size, and it does the same thing as size equals new size, with advantages. There's advantages to doing it that way. Compilers can also do more with it, because it doesn't. That's a whole topic. Let's not worry about it now. So I am going to have to allocate memory. I'm going to have to allocate enough memory to hold, 10 integers. And so for that, I'm going to use the new command. The new command in C++ allocates memory. And you might hear me say no news is good news, and that's true. But I'm going to show you at the, because I like working at a higher level most of the time. But I'm going to show you what, goes into making the vector class, because we're in a data structures class, and now you're going to get to learn about data structures and how data structures are made. Okay, so this is a very gentle introduction today. We'll do lots more during the semester. Don't worry. So we're going to make a new int size, new size. Okay, what do you guys think? So new returns a pointer. So it's going to new enough memory equal to hold 10 gets passed in here, 10 ints. So this is going to allocate 40 bytes of memory and return the start into R. So it's going to return a point. So it's going to allocate a chunk of RAM equal to 40 bytes, because we're passing it in there. Not every time, right? It's here. So it's going to allocate 40 bytes, and it's going to return a pointer to the let's see, camera's reversed. There we go. So the very first element in that array, it's going to return the pointer to it. So all that is an integer. All pointers are integers. There's actually nothing really complicated about pointers. When you call by reference, it's just passing in an integer. The integer it's a memory address. All pointers are integers. They're just memory addresses. It's the address of where the variable lives in RAM. And when you have an array like this, the memory address is the first element of that array in RAM. And so where's the end? Well, that's why we are going to write down the size, right? The size is going to hold how many elements we have. So we know the starting point and we know the ending point based on these two things, and we're good to go. Okay? Now, we need to access it, right? So let's write a getter and a setter, or an accessor and a mutator, whatever you want to put it. We could do the at function, but I guess we could do the at function. Yeah, sure. All right, and reference at. Return. We need to bounce check, right? With the at function bounce checks. So if if they're trying to access element 30, so if element 30 is greater than or equal to the size, so if you have a size 10 vector, if you try accessing element 10, that's out of bounds. A size 10 vector goes from 0 to 9. So if they pass in 10 or any number bigger than that, then die or whatever. Otherwise, we will return array element s, and we're good to go. So, oh, we should also probably initialize everybody in here, right? So, because we're a vector, we always initialize ourselves. For int I size ti equals 0, I is less than size I plus plus, array square bracket I equals 0. Initialize the array to 0. So all the elements in the array are going to be set to 0. We're going to zero fill the array, we say. For every element in the array, set that element in the array to be 0. What about every new needs a delete rule? Yeah, we'll get to that. I'll show you what's going to happen in just 1 second. We're gonna get to destructors in just 1 second. So we've got ourselves an at function. It's returning a reference, and the reason why we return a reference is because that will allow us to modify it. So we can do things like this. We would say cout vector dot at 5. And then we can set vector dot at 5 to be 42. And the reason why this works, is because we're actually returning a reference. So this is actually the memory address. That can be used as an L value, a memory address. Remember, an L value is anything that has a memory address, and that's actually returning the memory address of element 5 in the vector, and so you can actually write to it, and that'll actually work. C++ will handle that. Okay, and so compile main.cc. We're basically inventing the vector. It'd be cheating to just use one. Yeah. Why don't you use a vector? That's the thing. Yeah, and so interesting. That's what I was going to get to. It leaked memory. Let's turn off address sanitizer for a second though, because we need to talk. G++ -- standard equals C++ 20. Why not? With address sanitizer turned off. And so it prints out 0, then it prints out 42. Okay. So we printed out 0, because remember we 0 filled the array. We set the value to be 42, and then we did that. And if we try going out of bounds by saying accessing element 50 instead of 5, then that will die. So cool. And in honesty, we'd put in a better error message here, but yeah. So far, so good. We got a working vector. Now, why was it yelling at us? Well, Mr. Wolf said, "What about the rule that every new needs a delete?" Yes, that's what address sanitizer was complaining about. Address sanitizer was complaining that you knew something, but you didn't delete it. And so, what happens if you allocate memory and you don't deallocate it? Well, when you quit, it's fine. In this case, the memory leak is actually insignificant. And the reason why it's insignificant is because we're leaking memory at the very end of the program. And when the program terminates, the operating system comes in and says, okay, you allocated a gigabyte of RAM. Cool, I'm taking it all back now. You can't actually break the Linux server by leaking memory. Because the Linux box, the GNU/Linux, as I tend to call it these days, is it knows every time you call new, and it keeps track of it. There's basically a segment of memory that you own, and then when you quit, it just reclaims all that memory. So you can't break the operating system. When you leak memory, leaking memory is when you knew something. It's when you knew it and you don't delete it. When you leak memory, that memory is gone inside of your program, but it doesn't hurt the operating system or anything. Okay. So in this case, the leak is actually trivial, but it's a good idea to get into the habit of deleting any memory you allocate. So the rule is every new Firefox in place. It works fine. yeah, for 10 years. For 10 years, Firefox had a memory leak in it. Right? And they didn't fix it. And so if you left Firefox open, the memory usage would just climb over time. Because it would new memory and it wouldn't reclaim it. Because when they tried reclaiming it, it would crash. And so they just took out the delete. And they're like, just leave it. And just tell people to reboot Firefox once a week. It'll be fine. And so, yeah. So what we need is a destructor. What we need is a destructor. A destructor is the... it's just like, it's the rule. For every new, you need a delete. For every master, there must be an apprentice. For every light side Jedi, there must be a dark side Jedi. I don't know. Not really sure how that works. Because it doesn't seem to be very accurate. Okay. So a destructor is it looks a lot like a constructor. It doesn't have a return value. You see that? There's no return value. It's a function whose name, a destructor, is a function whose name is tilde, then the class name. Okay. And the destructor gets called when the object is destroyed, when it goes out of scope. Constructors, C stores are called when the variable is made. And they're also used for conversion. It's a bit of a trivia. Destructors are called when the variable goes out of scope. Okay. So right now, it's just going to print Destructor called. It's still going to leak memory. Okay. And so, when does a variable go out of scope? Well, when it hits the closed curly brace, right? And so this is where the constructor is going to get called. The destructor is going to get called here. Okay, so it's going to print 0. It's going to print 42. Then it's going to print dstore called. And then address sanitizer is going to bitch at us. Right, it prints at 0, prints at 42, prints at dstore, and then leak sanitizer has detected a memory leak. You did not destroy the memory you promised. You were supposed to bring balance to the force, not destroy it. So it'll tell you main.cc line 5. Yeah, so you allocate a leak. When you leak memory is when you allocate memory and you don't deallocate it. You're supposed to optimize the code, Anakin. Yeah. So we are going to do it right. Delete, array delete. C++ is weird. It has a different delete function for deleting arrays. Probably bad language design, honestly. Delete array. Okay. And this frees up the memory allocated in the constructor. Okay. You guys understand? So when the vector is made, it allocates memory, and then when it goes out of scope, it will deallocate the memory. The tilde means destructor. Tilde vector means destructor. When vec goes out of scope, it gets called. Okay, and it doesn't mean the end of program, right? I could make a new scope like if true, just whatever. I can make a new scope, right?
You don't even need the.
You don't even need if true. I know, but it'll confuse people. Trust me.
That's fair.
Yeah, this is actually valid C++. That is valid C++, but yeah, if true, vector vec of size 10,000. Okay, and so this is going to allocate 10,000 bytes of memory, initialize them all to 0, and then immediately deallocate it.
Wait, are those 8-bit ints? I'm confused why you're saying 10,000 bytes of memory.
Sorry, 10,000 elements, 40,000 bytes.
Okay.
And so it's going to print C store, D store, C store, D store. And the reason for that is because, yeah, and if I ever say something, just correct me. I make mistakes. I'm human. I'm not a machine. Computers don't make mistakes. So this will this line here calls the constructor, and then it immediately goes out of scope, and that's why we see that C store, D store, and then it immediately makes another vector C store, and then it prints out 0, prints out 42, and then it goes out of scope here and it prints D store. So do you guys see when the constructor and destructor are getting called? How is the braces valid code without if true? You can just make a scope. It's called an anonymous scope, I believe, and you can just yeah, that's the thing. And you'll use that sometime. Like, do you notice how this guy and this guy have the same name? The rule is you can't have two people with the same name in the same scope. So that won't compile because I've made vec twice. But that's perfectly fine because this guy exists in a different scope as this guy. Okay. And so I could even make a vector in the global space named vec as well. And all three of these guys have the same name, but they're all, and it'll compile. Like, it compiles fine. That's the global. And so the rule is, like, when you're talking about vec.at5, the rule is to always refer to the closest vec. So if we were to d3d, are you talking about vector, vector, vector? What's your vector, vector? What's your?
Is it sometimes give a warning like, oh, this variable shadows another variable?
Yeah, this is called variable shadowing, and the reason for that is because you don't want to have to keep track of the names of every variable you have in every scope. You're only responsible for names, for not having duplicate names in your current scope, and that's a lot more manageable. So even if you have a global named vec, when we're referring to this guy, it's referring to him. And here, when we're doing this guy, we're referring to him. Even though...
How would you... Is there a way to manually refer to the higher level vec?
No, I don't think so. If you use namespaces and things like that, you can. That's what the scope resolution operator does. There's things like that where you typically will put them into different namespaces, and then you could say like namespace A : vec, namespace B : vec. That's what the double colon is for. It's used for the scope resolution operator. And so here, this works, and that's referring to this guy because I commented him out, and now he's referring to this guy. I don't recommend writing code this way. In general, I consider shadowing bad practice, but you can see everything worked. When I printed out that guy, when I printed out his number 5, it was 0, right? Because it wasn't 42. Because this guy and this guy are two different things. Yeah. Vector, vector, vector. Vector, 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 vector. Okay. So in C++, there is a concept called RAII, or RAII, or people pronounce it different ways. It's RAII, which is a dumb acronym, meaning resource acquisition is initialization, but it's a dumb acronym. So just call it RAII, call it RAII, or RAII, and people will know what you're talking about. But what it means is allocate memory only in constructors and deallocate memory That's what it boils down to. RAII basically means if you do have to use a new, put it in your constructors. If you, yeah, like don't, yeah, just when you make the variable, allocate the memory, and when the variable goes away, delete should be in your destructor, new should be in your constructor, and there's more to it than that, but that's essentially what it's about. Okay, and if you follow this rule, you won't leak memory. If you do you guys understand? If you follow this code, basically can't leak memory. If you're very clever, you can get it to leak memory, but it basically won't leak memory. Okay. Do you guys understand? Positive side of the force, negative side of the force, right? It's impossible to have light without dark. If you do not bring balance to the force, then address sanitizer will yell at you for leaking memory. Okay, and this is actually really important. We're gonna be doing a lot with you guys making your own data structures. Like this is a fairly basic and not very functional vector, but it'll work. We need to add pushback and some other stuff to it, but what really the main thesis of today is this, right? Allocate memory here, deallocate memory here. Maybe next time we'll talk about smart pointers, which is a better way of doing this. When are you making classes of classes? You already could, dude. Every time you put a string, like that's a class, right? Or do you actually mean class? Yeah, you can do that too if you want. It's more niche. Inheritance we'll do later in the semester. I'm not a fan of inheritance, and since these YouTube lectures are on YouTube, I'm sure I will get a number of angry people saying, "What? How dare you not like inheritance?" And you know, there's uses for it. I'm not 100% opposed to it. I just think people use it way too much. And we'll talk more about inheritance later in the semester. But to me, inheritance is a solution in search of a problem in most cases. Yeah, if you do Java, there's inheritance everywhere in Java, for sure. But to me, it's just people that are afraid to write if statements. Inheritance is cool in biology, yeah. So string is a class that uses a vector internally. Yeah, a string is a vector with extra string-related stuff added to it. Okay. All right, we get there when we get there. Inheritance is bad and ugly and stupid and bad. Yeah. Good. I'm sure Mr. Wolf is going to get an A in the class now. He agreed with his professor. Always a good strategy. No, look. I'm opinionated, and I will tell you guys what my opinions are because it's just based on 30 years of programming or so. I will share my opinions with you, but at the same time, just be aware that people do disagree with me, and lots of people disagree with me on lots of things. And in fact, like this, using namespace standard, like most computer science professors would recoil in horror that I use it, despite the fact that it makes your code look a lot better. So, just be aware that, my views are not shared by everybody, despite me perhaps making it sound like they're not. And so lots of people love inheritance. They love it to death and will speak ill of anybody who dares criticize inheritance. But, to me, there's some problems that I use inheritance for, and most I don't. In most cases, it causes more problems than it solves. So, yeah, we'll talk about that later, though. So your homework is due on Monday. Your next zyBooks is due on Wednesday. The zyBooks reading is really short, so you should do it. It's half the size of the first one, and the first one is already pretty short, I think. So you should be able to knock it out in a few minutes. But it might be worth reading before you finish your homework because it's on this subject of ADTs and stuff like that. So, okay. that is it for today, guys. Have a great weekend, and I will see you on Monday. All right. If you have any questions, just message me. Oh, and the input tester is half up. I'll finish the rest of it later today. All right. See you guys.